Good morning students. Today we are learning a new lesson number 12, the halogens. The objectives are to identify the halogens. Second objective is to describe the physical properties of halogens. And the third objective is to explain the reactions of halogens with hydrogen. First, we are discussing the first objective to identify halogens. The periodic table is given there. In the periodic table that we already learned, the group 7, they are called halogens. There are 5 elements are mainly in this group. They are known as fluorine, chlorine, bromine, iodine and astatine. The first element in the halogen, it is fluorine, and the last element is astatine. This astatine is a radioactive element. All other elements are non radioactive. The name halogen means salt producing. This group, the seventh group elements are called as halogens because they are able to form salt. When they react with metals, these elements are producing salt. For example, sodium, it is a metal. It reacts with chlorine. It is producing sodium chloride. Next one, the potassium. It is also a metal. It reacts with iodine. It is able to form potassium iodide. Sodium chloride and potassium iodide are salt. So, these all elements, the seventh group elements are able to form salt with metal. So, the name is given halogens. Next, we are discussing the physical state and color. Here, the halogen is given fluorine, chlorine, bromine and iodine. Astatine is not given here because it is highly radioactive element. The radioactive elements we will discuss later. First we consider fluorine. Fluorine, it is in the form of gas. Its physical state at room temperature. That means at our atmospheric temperature, it found as a gas. And its formula is F2. 2 fluorine combined to form F2 and it is in the form of gas. What is the color of fluorine gas? It is yellow in color. Next, chlorine. Chlorine also in the form of Cl2. It also in the form of gas. What is the color of this gas? It is a green gas. Next one, bromine. Bromine, it also found as Br2. This Br2 in the physical state, it is a liquid state at room temperature. And what is the color? It is red-brown liquid. Its color is red-brown and sometimes the orange-brown vapor. That means if the temperature little rises, it is able to form orange-brown vapors. Next one, iodine. Iodine, it is a solid. It is the solid halogen. Only one solid halogen, that is iodine. What is the color of this solid iodine? Iodine also exists in the form of I2. It is grey color. Grey colored solid, or if it is forming, the temperature increases, it is able to form the vapors, but the vapor it seemed to be purple in color. So, these are about the physical state and color of halogens. Physical properties of halogens. The boiling and melting point increases down the group. If we are moving from top to bottom in a group, the boiling and melting point of halogens are increasing. Next one, they are non-metals and are poor conductor of heat and electricity. And we already know the seventh group elements. Seventh group elements means they are showing accepting electron tendency and they are non-metals. If it is a non-metal, it is a poor conductor of heat and electricity also. The mass of halogens increases down the group because the number of shells and the size is increasing. If we consider the mass of halogen, it is increases down the group. We know when you are going from top to bottom in a group, the size is increasing because the shell is also increasing. So if the shell is increasing, the size is increasing, so the mass also increases. So these are the three main physical properties of halogens. Next we have to discuss about the safety. All halogens are extremely poisonous vapors and have to be handled in a fume cupboard. That means these halogens, they are gases, mainly they are gases, and also it is a poisonous gas. It is producing poisonous vapors, so great care should be taken to handle the halogens. It is stored in a fume cupboard, means it is in a closed cupboard. The fumes are not coming outside. And we know the fluorine. Fluorine is a very dangerous gas. So we cannot found this fluorine in the laboratory also. We are not keeping the school lab and all. We are not keeping fluorine gases because it is extremely poisonous. Liquid bromine is also very corrosive and great care has to be taken to keep it off the skin. Because we know the bromine is liquid state. Bromine it is in liquid state, but if even it is a liquid state, also it is very corrosive. Don't touch it with our hands. So great care has to be taken. And if it come to our skin, it will be dangerous to our skin. So care must be taken to handle all the halogens. Next, very few chemical properties discussing. The halogens have 7 electrons in its outer shell. That we know. All the 7th group elements, they have 7 electrons in its outer shell. If they have 7 electrons in the outer shell, if it chemically combines, they forms -1 ion. They are accepting electrons. How many electrons they can accept? Only 1 electron, because already 7 is there. They have to make 8 electrons, so they need 1 more electron. So it is easily accepting this 1 electron and forming -1 ion in a chemical reaction or in the chemical compounds. And the next one, halogen itself, it is able to form diatomic molecules. That I already told you. Fluorine in the nature exists as F2. Chlorine, Cl2. Iodine, I2. Bromine, B2. That means diatomic. It is combining. There is a possibility of combining 2 chlorine molecules. When you take fluorine from the atmosphere, it is in the form of F2. It is in the form of diatomic molecule. Chlorine we are taking means it is in the form of Cl2, because one single existence is not possible. They are very reactive and they are combining with other halogens, with the same halogen, combining together and is forming diatomic molecules. Next, we are discussing the last objective, that is the reactions of halogens with the hydrogen. The halogens are able to react with hydrogen. The halogens react with hydrogen to form hydrogen halides. Generally we can call it as a hydrogen halide, hydrogen plus halogen. The name given for the compound, general name, it is hydrogen halide. Hydrogen plus bromine, hydrogen bromide. Hydrogen bromide means it is a hydrogen halide, because halide means it is the name given for halogen. So hydrogen halide. Here we used bromine, so we can call it as a bromide. Hydrogen plus chlorine. What is the product? Hydrogen chloride. Same way hydrogen plus iodine means hydrogen iodide. Hydrogen plus bromine, hydrogen bromide. Hydrogen plus fluorine, hydrogen fluoride. Like that the compounds are forming. These hydrogen halides are also poisonous gases, and they shows acidic character. Halides, they are acidic in nature and is able to form poisonous gases. That means these hydrogen halides, even it may say hydrogen bromide, hydrogen chloride, hydrogen fluoride or hydrogen iodide, they are poisonous gases and it shows acidic character. They are soluble in water and are able to form acidic solution. If it is soluble in water, we are getting acidic solution. Hydrogen bromide. and we know hydrogen chloride. Hydrogen chloride, it is producing hydrochloric acid. How hydrogen chloride is producing hydrochloric acid? Because we take hydrogen chloride, it is in the form of gas and dissolve into water. Then we are getting a solution of hydrogen chloride that is known as hydrochloric acid. The same way we are getting other hydrogen halide. It's also soluble in water to form respective acids. So these are about the halogens. I hope you all understood the lesson well. Thank you and have a nice day.